Good morning to one and all present here. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. Rajalakshmi, College of Arts and Science, Coimbatore. Today we are discussing about understanding ACID properties in database management system. This is for agenda, understanding ACID properties in database management system. First one is introduction to ACID properties and atomicity and consistency and isolation, durability and ACID properties in real world applications and ACID based properties and the benefits of ACID properties, challenges and limitations and ACID in modern databases. Then future of ACID properties and conclusion. First we discuss about what is the introduction to ACID properties. First of all, what is the atomicity? The atomicity, it is guarantees that transaction to all the nothing, ensuring all the complete execution or no changes. It is guarantees is a transaction for all the data informations. Then what is the consistency? The consistency is ensure the data validity and which is transforming the database from one value to the state another after transactions. And durability overview. The durability assert that once the transaction is successfully completes, it changes remain the permanent despite of failures. Next is atomicity. The atomicity is there are three types. The first one is understanding transaction rollback and real world example I will given and important in reliability. The understanding the transaction rollback in case of some of the failure of transaction time, the restore the database easily we can automatically transaction from this account. That is called as rollback. Suppose real world examples I given some of the atomicity, it is a completely automatically easily we can transaction from one account to another account. If you failure this account, easily we can get back of this the bank account from this money, whatever maybe. It is a best example. It is a real world example. Next one is the importance in reliability. The atomicity is vital for preventing partial updates that could lead to data corruption and inconsistency. What is meant by the consistency is ensure that all the transaction, the alter the data ways, the define some constraints. So data consistency is transaction only easy we can alter for all the data defined is constraint wise. Next one is what is the data integrity. The data integrity is nothing but it is maintaining the integrity. The consistency prevents illegal states through the enforced rules on database transition. The example of constraints, for instance, in the instance of the unique constraints, stop the duplicate entries if accuracy of data information. Next one is what is the isolation. The isolation is ensure the transaction ensures that they execute the independently, the minimizing the potential for interference between the concurrent operation and preventing the dirty reads. Through isolation system avoid dirty reads, the ensuring transaction do not access the uncommitted data from others. And it is which means it is avoid the dirty reads, ensuring all the transaction do not access from the uncommitted data from others. That is meaning of the preventing dirty reads. And impact on performance, while enhancing the data integrity, the strict isolation may affect the performance by reducing the concurrency by transaction processing. It is data integrity, it will be enhancing for the if you affect the some of the performance and the reducing the concurrency at the time, and easily we can data between the processing is very important for transaction. So that is the main impact of this performance. Next one is what is the durability. The durability, it is a guarantee transaction performance. Some of the despite of failures, ensuring the committed the changes, the survives the system, disturbances like outages. The power outage is example for the bank transfer, and it is a outage of some of the post commit. Some changes, some remain the intact and retrievable. It is a best example. If we want go the bank, it is a we are using to the ATM card and whatever may be the transaction time. Suppose the maybe the power of the system, easily we can retrieve for this account from this data. For example, for money, easily retrieve for your money for your account. And what is the critical role in system? The durability is essential user trust, assuring that critical transactions are reliably preserved amidst of failures. And ACID properties in real world application, we are using the ACID in banking system and e-commerce applications and real time impact. The banking system is maintained for integrity, the preventing the loss of during the monitoring of exchanges, and e-commerce application is platform leverage the ACID principle to secure the transactions, the improving the customer confidence and safeguarding sensitive information, and real-time impact. The implementing the ACID allows real-time processing, the minimizing risk during the high-volume transaction period on various online platforms. And ACID with base properties. The ACID base properties they empathize the availability and eventual consistency, allowing trade-off and the loosened of constraint in databases, and comparison with ACID. Unlike ACID's strictness, the base favor of flexibility and prompting the speed and availability at the cost of immediate consistency. And use cases of for base and common use case include the distributed system and application demanding high availability like social network and IoT platforms. The benefits of ACID properties: the enhanced data reliability and integrity maintenance and prevention of data anomalies. And enhanced data reliability is ensure that transactions are committed reliably and reducing the risk of data loss significantly. And integrity maintenance, the principle enforce rules of preventing the violations and thereby maintaining the data integrity across complex transactional system, and the prevention of data anomalies by adhering to ACID. Typical anomalies such as lost updates or dirty reads are effectively mitigated.